Bright lights, that means go time. All right, before I start, just want to let you know the people from the video setup told me that they have a fancy new camera that follows me around using AI, so I'm going to be running around. I want to test that thing. Um, Kidding aside, good morning, everyone. Thank you for joining me here on the third day of NDC already. Um, it's been a good one for me. I saw a lot of interesting things. And this one might be different from what you saw. A lot of the different talks that you've seen are how should you do this? What's the best way to do this? What's the best practice to use this specific thing? This presentation is a war story. This is an actual project that we did. Me as an architect with an entire team, I will dive into more details about the team setup later, but this is an actual project with a customer making his own decisions that we had to work around because customers, right? Who here is a consultant who works with customers? Bunch of people? Okay. So hopefully, and in other places where I've done this particular presentation, the problems we encountered really resonated with other consultants, with other people who have to deal with clients. So hopefully that's the case here as well, so we can share our pain. That's it. Hello, everyone. My name is Nico. I'm a senior application architect at a consultancy agency in Belgium called Initum. I've been a Microsoft MVP since 2014. Back home, I run some stuff, user group. I also help run a conference called Tekorama. And I do a bunch of other stuff. If you want to follow me around, I'm mostly active on Blue Sky, a little bit on LinkedIn, but that's the only social medias where you can reach me these days. So if you're on Blue Sky, give me a follow. Much appreciated. If you have any questions after this talk, you can find me running around here somewhere. If you think of questions in the coming days, reach out. I'll be happy to respond. Okay, setting some expectations about this talk. I'm going to show you how we used Aspire and Dapr in this particular project. I'm going to be ranting on my customer because they made stupid decisions. So that's a big part of this talk. I will also explain why we made certain decisions and how those decisions do not really fit into the demos that you've seen of Aspire and maybe Dapr. But that's kind of how it goes. Now, unfortunately, I can't really talk about the actual project. That is to say, I cannot name the customer. I cannot name the project. I can say that it was government, which should tell you a lot. But that's about it. Now, what did I do? I created some replica codes that kind of mimics the project in places that are important. I took some screenshots of code. I took some screenshots of the Aspire dashboard, blacked out the things that they probably don't want you to see. But that should be sufficient to give you a good idea on what we did. Okay, so this project got started February last year. I got pulled in January as one of two architects. And just to give you an idea, when the team was at its biggest, there were two architects, there were 5 developers, 4 people doing analysis, 3 people doing QA, 2 PMs, Scrum Master, and I think 2 or 3 proxy POs. Really, really big team. This project was 3 million in 1 year, euros. Now, when we got started, customer said, we haven't decided on where we want to host this thing. This will either be the very first cloud project that we do, or it will be hosted on our on-prem Kubernetes cluster, which we are currently setting up. But if it would be cloud, which we were really pushing towards to, then the cloud environment will be set up by a different company. They will create a cloud center of excellence. You will have to discuss with them. They will give you your resources. You will not be in control of the cloud environment, which kind of makes sense. And because of this, they told us, because we haven't decided yet on where to host, you need to use Terraform for infrastructure as code. Who has ever used Terraform? Ooh, a lot of people. I'm so sorry. The reason they pushed Terraform to us was, and I quote this literally, with Terraform, you can start on Kubernetes, and if you do decide to go Azure, you can just take it and deploy to Azure without any change. That's not how Terraform works. But we couldn't convince them otherwise, so we were stuck on Terraform. And this is important because Aspire comes with a full deployment story as well, which does not support Terraform. So there was that. The technology stack was ASP.NET Core API in the backend. It was Blazor server in the front end with SQL Server databases. Why? Because they were already doing quite a lot of internal development. This was the tech stack that they had. This was the one that they used. They were happy with it. We had nothing against it. It's a decent stack. It's a good stack. So that's what we went with. Then came the authentication authorization story. That was Identity Server 3 on-prem. That was set up. We had to use that. Fully configured with a bunch of users, a bunch of roles. This was what we had to use. Now, if you don't know Identity Server, the people from Duende are right on the other side of this curtain. They are not on version 3 anymore. Version 3 is out of support for a long time. But that was what they had. No upgrade was possible. We had to use this. Okay, fine. Can we get access to a test environment of Identity Server? No. Okay. But then how would we be able to test our login system, our authorization, our authentication? Oh, we will give you a local STS project that you can include in your solution that you can reference. It's based on Duende Identity Server 4. Okay. But do at least the roles and the users match? Not really, but it should be close enough. Okay, fine. Oh, by the way, they told us, we have a library of Blazor components that you need to use so that every application that we build in Blazor has the same look and feel. Sounds reasonable. That's been created by a different third party, and we were the first application to use that, meaning we got to discover all the bugs and report those back to the team that would put them on the backlog somewhere way down. So by now, we need to deal with the actual customer itself. We need to deal with the CCOE, Cloud Center of Excellence. We need to deal with the component builders. And then we had our own team, 4 parties building this thing. Eventually, they went for cloud. So spoiler alert, it was cloud. So in order to tackle that, we made a decision to go with Dapr. Because Dapr, and I will go into more detail on what Dapr is. Oh, maybe first, who has used Dapr before? Okay, some people. Aspire? Okay, cool. It's not a majority, so I will do a quick overview of what both Dapr and Aspire are before I go into how we used it, just to make sure we're all on the same level. So Dapr is basically an abstraction layer on top of a bunch of stuff. I have a nice diagram coming up. But we use that to put an abstraction on top of things like storage or service discovery. In order to, if we would deploy to cloud, it will work. If you would deploy to Kubernetes, it will work as well. So that was a nice way to already get started. With Aspire, it would enable stuff like a faster inner development loop. Things would start up way faster because you don't have to configure your multiple starter projects and stuff. Working with containers is easier, just hooking all the resources up together. That was the excuse that we used against our customer. But having 2 architects that are really into tech, we just wanted to use this. We heard about it, it sounded fun, we need an excuse to use this, and the customer went along. In the end, it turned out really good. It really, really helped us. I'm a big fan. The thing is, at the time, Aspire was on preview 2. So really, really early days, which also meant that you needed to use Visual Studio Preview in order to use Aspire. So once we convinced our customer about Aspire, we told them, well, there's this one small extra thing. We'll need to use Visual Studio beta versions. Oh yeah, that's fine. Just do it. So that's what we did. And then we kept upgrading with every preview release that came out. And then we went to GA, and it's been really, really good. Okay, so quick timeline of the project. January, everything got started. We started doing meetings, decisions were made. February, the team started pulling in developers. We started doing actual development work with Aspire Preview 2. Once we got started, a week later, they released Preview 3. It took us a full day to upgrade. There was not a lot of code in there yet, but these were preview versions, so a lot of breaking changes every single time. So it took us a full day to upgrade. Didn't really matter. By the way, this was a fixed scope, fixed budget project, so it didn't really matter to the customer how long an upgrade took. We needed to make the deadline, and it was our responsibility. In March, Preview 4 got released. That was kind of an easy upgrade. But then going to Preview 5 in April, that was a big one. Because they did a lot of renaming and refactoring in Aspire at the time. I think they went from integrations to components, or the other way. I don't remember, but there was a big change there. And that upgrade was a really, really big one. I think that took us 2 or 3 days to do. And us, meaning one dev was assigned to upgrade Aspire to the new version. I took him, so 2-3 man days. In the same month, Preview 6 arrived, quite an easy upgrade. In May, there was a final upgrade, and then they went GA at build at the time. Going from Preview 7 to GA was again a difficult one. But we took the time, and that also meant we could go back to Visual Studio Stable. So we were again in a stable environment. Then in June, we still had no Azure resources at that time. The decision on cloud had been made. We knew we were going to Azure. And then our customer said, we are working on creating the Cloud Center of Excellence. It's being set up, it's coming, don't worry. Yeah, but when will we have our landing zones? Oh, you'll have them by October. Deadline of the project was November. So that will not work because we have acceptance coming up. Okay, you know what we'll do? We'll hire another partner, another external company that will set up temporary landing zones for you. So you can at least start building your Terraform scripts, you can start deploying, you can start testing. Good. That happened. In June, we got those. We started, I did a Terraform script. That's why I know what it's like. I did the scripts, everything got deployed, everything was running, everything got smooth. Then in August, they told us, we have good news. The real landing zones are already here. Oh, okay. They look nothing like the temporary ones. Completely different. So I had to rework all the scripts in order to deploy into the new landing zones. That took a lot of time. Eventually that worked. In September, we got an email saying, those final landing zones were not so final. We're going to replace them with, again, new landing zones. Because we came into new insights. Okay. By November, Aspire 9 got released. I got moved on to the next project. The team is still working on it. I think the first version is currently in production. And they have upgraded to Aspire 9, and they keep having really good experiences with it. So that's a bit of timeline. Now let's talk architecture. The project is kind of distributed, but it's not a microservices project in any way. It's two separate front-end, back-end applications that talk to each other. That's it. One tool is internal, one tool is external, customer-facing. So our customer has internal people configuring everything through a web UI, which is one of the two web front ends here on the diagram. The other one is facing their customers, and they get to interact with the system that way. So two front ends, both Blazor, two web APIs, they both connect to the same database. Why? Because our customer wanted it that way, because two databases were too expensive. Fine. We didn't really care about that. There's two different schemas in there, one for each project. The internal facing app is used by 4 people a couple of times a year. So it was not that bad to have one database for both. Then there are a bunch of external APIs, APIs that are being hosted on-prem of our customer that we needed to contact in order to get certain information. Talking about protocols, we communicate with our own APIs through HTTP. The external APIs, and one of them is the Identity Server 3, by the way. The external APIs are being done through HTTP, gRPC, combination of those. All being built by internal teams, but that communication went quite well. So hosting, this part is on-prem. That part runs in Azure. That part is Azure Container Apps. One Azure Container Apps environment, 4 containers. And then the database was an Azure SQL database. That was the setup. And because we are using Dapr, we have sidecars. Now, the sidecar pattern is a container pattern where Dapr really relies on to do its work. So a quick sidestep into what Dapr is. This is a diagram coming from their website. So Dapr is technology agnostic. It's an open source framework, stands for Distributed Application Runtime. It's written in Go, but it has SDKs for all these languages that you see on the top here. Microsoft is involved. They don't own it. It's a lot of people together that own the thing. And it has a bunch of building blocks. Like you can do workflows, you can do pubs up. There's an actors framework in there. There's secret management. Service invocation is what we used heavily. State management we used as well. There we go. Those are the 2 building blocks that we used. There's way more in there. Now, what do I mean with these building blocks? These are basically abstractions. You have one SDK that you use, the Dapr SDK. It works in a very similar way across all those technologies, and it abstracts away the underlying implementation. For example, let's take the secrets building block. You just define Dapr secrets. It's all YAML. And in that YAML file, you define that in this environment, I want to go to Azure Key Vault. And when you run it, the SDK will load in the configuration file, and you will actually go to the Key Vault that you specified. You want to do this on AWS. There's a different thing, I forgot the name, but it does the same thing basically. And you don't have to change your Dapr code because you just change a config, and it will go to that one. That's what it does. It's an abstraction layer. Now, I told you we are using Azure Container Apps, and Azure Container Apps has native support for Dapr. It's right there. This is a screenshot of the Azure portal. It has a Dapr entry there. It's natively supported. You just specify that you enable Dapr, you specify an app ID, protocol that you want to use, and that's basically it. You can do some extra configuration there, and that just works. Now, I spoke to you about the sidecar pattern, and the sidecar pattern is basically, you know, a motorcycle that has a sidecar attached to it. The sidecar cannot do anything on its own; it needs to be attached to the motorcycle. That's basically it. You have your container running, and you have an extra container that's connected to it. And all it does is it enables new features to that container. It cannot do anything on its own. It needs the container that it's attached to. That's what the sidecar pattern is. And this is what Dapr is relying on heavily. Because Dapr lives in that sidecar. All the abstractions that you build, all the configuration runs in that sidecar. For example, if you want to make an API call and you use Dapr Service Discovery, the only thing you do in your SDK is you call invoke method async. You pass in the application ID, which was here. You see app ID in the portal. You pass in that ID. You pass in the method that you want to call, your REST method. And what will happen is your front end will, using the SDK, will pass that command into the sidecar. The sidecar will look at it, will go, I know this app ID. I know where that lives. I know where the sidecar lives of that API. It passes that command along to the sidecar of the backend. That sidecar forms the actual HTTP request, the actual REST call, forwards that to the API, and the result comes back. So yes, it's a bunch of extra hops. You go front end, sidecar, 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 backend. But you get a lot of flexibility in return. Pure from a reasoning standpoint, I would say, yes, you take a performance hit. But if I run the metrics, sometimes doing the call directly is even slower. I can really put my finger on it. Reason dictates that you take a performance hit because you're doing extra hops. Now, the hops between sidecars are by default done over gRPC. So they are way faster than simple HTTP calls. There's that. Just another really quick Dapr thing. This demonstrates the different building blocks and examples of implementation. Like, again, going with secrets, you have the AWS Secrets Manager, there's the one, there's the Azure Key Vault, there's a Google Cloud Secret Manager, and so on. For PubSub, you can do Azure Service Bus, you can do Redis, you can do RabbitMQ. There's many possibilities. And again, you don't need to change your code if you want to change implementation. You just adjust the config file, that's it. Also makes it quite easy to differentiate between local development and deployed. For example, we used the state store to upload files. Locally, it just deploys to the file system. Once deployed, it goes to Azure file storage, blob storage. So you can differentiate between environments there quite easily. Now, enough PowerPoint for a while. Let me quickly show you what this looked like. So I'm just going to create a new project, create a new web API. Promise it's quite a quick demo, just to give you an idea what Dapr looks like. Let's create it. All right, and I'm just going to add a front-end project to it. Front-end being Blazor. There we go. Now, normally, everything that you do with Dapr, you would do outside of Visual Studio. You would create the YAML files manually and so on. But there is a Visual Studio extension for Dapr, an official one, that gives you things like right-click, add Dapr run file. If you click this, it will inspect your solution. It will create a sort of Dapr project. This is not an actual project. It's a virtual thing with the Dapr YAML file. And you can set this as a startup project. Let's increase this a bit. Is that big enough? Yep. All right. This one can go. Okay, so what this did is it inspected my solution. And now I have two entries in my Dapr run file, one for every project in there. I have three projects in there. One is the Blazor server with the Blazor WebAssembly, which is the default Blazor template these days. So there were three entries in there. I just removed the one that's only WebAssembly because that one gets started from the ASP.NET host. So remove that. So by default, it has an app directory path. It generates an app ID based on the project name. It assigns a port, gives a few commands, and that's it. So normally, you would do from the command line dapr run -f dapr.yaml. This would inspect your Dapr file. It will boot up everything, every application that's defined in there. It will load in extra configuration files if you have them. Everything will start up. You get ports here, and everything starts working. But you're still dealing with YAML files. Even though the extension helps, you're still dealing with YAML. So quickly going back here. Okay, so why did we do that? Again, small repetition. Why did we go with Dapr? For the abstraction, purely that. Because we were waiting on hosting decisions, we needed to find a way to get started. And Dapr got us there. It bought us some time. Didn't do anything else than that. If this wasn't the case, would we have gone with Dapr? Probably not. I do see some advantages in using it. I don't quite see it as a necessity at the time. But you never know. All right. Second part of the project was Aspire. Aspire is a framework, a stack, an opinionated thing coming out of Microsoft that provides a C# way of defining your system. It's not infrastructure as code. is just a way to define your distributed system, to hook everything up. You know what? I'll just go show you, which is easier than explaining things over a slide. So, file, new, projects. Aspire 9.3 just got released. So there's a Aspire starter app template. In here, you have some options. You can select the version now. This is new. You can enable Redis automatically, have some XUnit in there. Depending on what you select, you do need to have Docker Desktop or some container runtime installed. Visual Studio integrates really well with Docker Desktop, so that's what I'm running now. All right, let's see. For those of you who have never seen Aspire before, this is a Aspire project. Out of the box, you get a backend, API service, you get a front end, which is Blazor again, you get a test project, which in this case was XUnit. You get service defaults and the app host. Now, what is this? Service defaults is a bunch of extension methods that add stuff like health checks, open telemetry, service discovery is being set up here, resiliency. You can set up whatever you want here. If you want to do application insights, you can just add it here. Azure monitoring, for example, you just paste a connection string and it's good to go. And these extension methods, if you go look in the program CS of the backend, for example, you see them being called here, meaning that all the projects in this solution have the same default service defaults, the same logging that they go to, the same cache, the same whatever. It's all defined in the service defaults, which is a neat way, but it's nothing special. It's just extension methods. The real magic of Aspire is in the app host. This is the apphost.cs. It relies on the builder pattern that got introduced with ASP.NET Core, but they have a distributed application builder. Yep. And you basically define your projects here. So the Redis cache is being defined here. It's just a variable that you have done. Then there's the API service and there's the backend. There is some source generation going on here. For every project that gets referenced by the app host, it will generate, where's my F12? It will generate this. This is just a class pointing to the CSprosh file of the thing that you referenced. This means that in Aspire, you can hook things up together in a hard typed, strongly typed way. Going back here, you see that the API service also gets saved as a variable. And where we define the front end, we add a reference to the API service. What this will do runtime is Aspire will detect on what base URL your API will live. You will get that base URL and it will inject it as an environment variable in your front end. That's the way service discovery works in Aspire. So nowhere in the front end code, and I can actually show you this, because there is this, you've all seen this template, right? It just calls fake weather data from the API. Going here, this is the base URL that's being set in the HTTP client on the front end. It's just called API service. There's no local hosts and then app settings that define everything per environment. It's just API service. Jumping back to the app host, this is the name that we give to our API service. This is the app ID. So based on that, Aspire will just inject the actual URL here as through environment variables. That's how it works. Now, if I run this, then you will see a fancy dashboard. There we go. And if you saw, these are the services that got defined, right? There's the Redis cache, there's the backend, there's the front end. When this started up, a bunch of those were in orange saying unhealthy. The status here relies on health checks, the default health checks that get added through the service defaults. And as long as they are not returning healthy, this will be in an unhealthy state, but it keeps updating. So now everything is running. This is my dashboard. So the source where everything is coming from, Redis is running in a Docker container currently, the different URLs where everything is hosted, and I have some actions here. I can stop and start every single resource that I have here. Meaning if I want to, I can just edit and continue my code from my backend, for example, and just restart the backend, and things will work. This was stuff that we did not have when we got started on the project. We had to stop the whole thing every single time for every change and had to restart it. Every service had to pop up. Even worse, our database also was defined in the app host, meaning that the connection string gets generated automatically as well, which is really neat. But there was no way to tell Aspire, do not spin down the SQL container, because it was SQL Server in a Docker container. So every time we stopped running our application, stopped debugging, the container went down. The database was still there because of Docker volumes, but we had to wait every single time for the container to boot up again, for SQL service to launch, to pull in the database again. That took a lot of time. All of that got fixed now, over time. There's a fun graph that's quite new. This has been here since 9.2, I believe. So this has nice animations, which is fun to play with, and shows the different connections. New in 9.3 is that you can right-click it, ask it some details, and of course there's AI in it now. Because AI, all the things, even the cameras. There's a console where you can just select whatever service, and you see the console output. That's fun. Oh wait, let me go here. Launch the front end, pull in the weather data, refresh a couple of times, go back here, and then we go to traces. So these are all the live traces of my application as it's running. There's a bunch of stuff going on. There should be, here's the weather call. So here you can see that my front end, and you can click through on this, my front end did an API call, checked the cache first to check if the data is already there. Data was not there. So it went to the API to get stuff. And you can nicely see how long everything took. Going back to the traces, if we refresh, you see that it only goes to the cache and it gets data from there. So you can nicely see the flow of your application. Fun. Now, what we did was we integrated Aspire and Dapr together, right? So all of this service discovery, we replaced that with Dapr service discovery because they do basically the same thing, only through the sidecar pattern instead of environment variables. So in order to do that, you can go to the app host, add a NuGet package called aspire.hosting.dapr, but that's not the one because it's deprecated. It's the community toolkit one. There's a community toolkit for Aspire as well, with a bunch of stuff, including Dapr hosting. Okay, so keep in mind, the Dapr demo I did was with YAML. You have to define everything in YAML, even though it was generated for now. So what I can do now, I can do, is it with? No, it's at. No, what was it? Build little web projects, okay, add Dapr sidecar. Why aren't you doing your thing? It's with Dapr sidecar. I always mix those two up. So this is the Dapr API with Dapr sidecar. There we go. This is the Dapr UI. That's it. No more YAML. Aspire will now generate the Dapr run file for me in the background, and I will never have to see it. If I run this again, you will see that the dashboard has more entries. And those entries are the Dapr sidecars. See? And now it's nicely layered. So those Dapr CLI instances, those are the sidecars that are running. Now, if you run these things locally, then your sidecar is not an actual container. It's an executable that's running. If you deploy this to a container-based environment, then the sidecars run as containers. Just to show you what that looks like. Details. So there's Dapr and Dapr-D processes running. Dapr-D is the actual Dapr runtime. Dapr.exe is the sidecar. Okay, so Dapr is up and running now. Didn't need to do much for that. Meaning I can now go to my front end and I can add the Dapr SDK. Now, I'm configuring everything through Aspire, but in my client project itself, I'm just using the normal Dapr SDK. It doesn't need to know how I set everything up. It doesn't need to know that I'm using an app host, defined everything in C# instead of in YAML. Everything is just transparent for the SDK. All right, so this is the weather API client that you get by default in the starter template. It injects an HTTP client. It calls get from JSON, and then it parses that. That's what it does. We can replace this with the Dapr client, which is the SDK. So like this, rename all the things. Have to remove this. Have to add that. Yes. Dapr client dot invoke method async, which means that we're doing a HTTP methods call. I'm expecting an array of weather forecasts to return. Needs to do a get method. The app ID was Dapr API, if I remember correctly. The method I'm invoking is weather forecast, which is really just the REST resource, right? So it's localhost whatever / weather forecast. That's the one I'm calling. Where are we? And then there's the cancellation token. That's basically it. Now we just have to jump to program.cs. We no longer need this because this is configuring HTTP client with service discovery. We don't want that anymore. Instead, we're doing builder.services.add Dapr client. This will register the Dapr client into my DI container. So let's add scope. So what's it called? Weather API client. Now I have to register the weather API client in the DI container as well, because that happens automatically with the add HTTP client before. But since we're not going through HTTP client anymore, I need that in there. Just to prove to you that I'm not lying about anything, this is the weather page. It injects the weather API client and calls the get weather async. If I have 12 into that, we're at the part where we inject the Dapr client. So everything is hooked up. This is my API. This is the weather forecast. I'm just setting a breakpoint here to show you that we actually reach it. And then we'll see what happens. There we go. Everything up and running. Open the front end. Call the weather API. I'm in my backend. Continue. Everything is still working. Nice. Now, if I go to my traces in the Aspire dashboard, I take this one. Then you will see that my front end called the get weather thing went to the Redis cache. There was nothing there. So the get request got forwarded into the Dapr sidecar. That got forwarded into the Dapr sidecar of the API service to end up in the actual API service. This trace can nicely shows you how the sidecar pattern works. All right. So that's how you set up Dapr with Aspire. Makes it easy because you no longer need to do YAML. Now, for certain configurations, you would still like to have all the flexibility that the YAML config files give you in Dapr. You can just add that, and then through some of the Aspire methods, you can still reference that config file. I have an example of that, how we use it in the project, somewhere further in the slides. But from here on, we kept building on. Things you can do, for example, is storage builder dot at Dapr state store. And then you can just say with reference storage. And now whatever I configure as state storage gets nicely injected, connection string gets injected into my API, or my front end in this case. Now, if you have a service running somewhere and you just need to add the connection string, for example, for application insights, you can do builder.add connection string and add your application insight connection string right there. So all of that stuff just simply works. And then you can reference it here with reference app insights. And you can keep building on that. Now, the app host, in our case, got quite large. So we started splitting it up using extension methods. So it's also nicely structured for every project that we have. And jumping back here to show you our dashboards. This is an older version of the dashboard. This is not the one that I've just shown you. That upgrade hasn't happened yet. So you'll see the different executables that you see. Those are the Dapr sidecars. They are not layered underneath the containers that they're attached to, because that was a newer feature of the dashboard. But we have quite a lot of different stuffs in there. The top one has a type that says container. That was our SQL server, the actual server, because the bottom one was the database. So both show up in there, because both of them are defined as different resources in Aspire as well. You don't see it anymore. So you have the top record there, the container. Next to the name, there is now, but I blacked it out by accident. There's a pin, meaning that this has a persistent lifetime defined. So the container will not spin down if you stop running Aspire or your project, which saved us a lot of time. Stuff like that really improved our quality of life while we were building the thing. And we got lucky to come into contact with the Aspire team because we were one of the early adopters. They wanted our feedback. We wanted to know where they were thinking of going with things. We spent a lot of time thinking of where does Dapr end and where does Aspire begin, because there's a lot of overlap between the two. And basically, we asked the team, and they didn't have a real answer to that either. And what we found out is that it kind of depends on what you want. You can go all in on Dapr and just use Aspire to hook everything up to avoid having to use a YAML, but you don't have to. You can mix and match whatever you want. So Dapr ends and Aspire starts wherever you want, what works for your project. Now, if you look closely, there's the state column, and there are two of them that are in the finished state. Those are worker projects, and those are entity framework migrations. Because because Aspire generates connection strings and injects them as environment variables, it's not as easy to do migrations as you would in a normal API project. So in order to tackle that, we put our migrations in a separate project, which has background workers. And those will start up, they will do the migrations, and then they will just exit with exit code 0, and that's why they come in a finished state and not in an error state. Now, when we first did this, when we first did this, there was no way for a resource to wait for another resource. Everything just spun up at the same time. Meaning, our API was trying to contact a database that was not ready yet because it was still being migrated. So we had to write a bunch of retry logic. And sometimes that retry had to reach 10, 15 retries before it could spin up, throwing a bunch of errors, stack traces in our output, in our logs. That got fixed because you can now add in your app host wait for. So resource can wait for another resource. That was a big quality of life improvement for us. It kept our logs a bit cleaner. That was expensive. We push this through to our container apps as init containers. Azure Container Apps is an abstraction layer on top of Kubernetes. Kubernetes has a thing called init containers, which is basically a container that will execute work, and only if it exits successfully, your main container will spin up, which sounds kind of perfect for migrations, so that's how we use it. Now, init containers do not show up in the portal for Azure Container Apps. If you just base yourself on the Azure portal, it looks like it's not supported. But through our Terraform setup, we were able to set it up, and it works. It works pretty well. And then if you go into the portal, you can export the resource as JSON. In there, the init container will show up. So that just works. All right. This is a snippet of our app host. So you see on top, add project DB migrations. That's our migration project being added. And then you have our API that references the SQL database. It references the storage, which is Azure storage. We inject environment variables ourselves, which is the authority of the identity server. In order to set up your OAuth flow, your OpenID Connect flow, you need to have that authority. And app settings is not really used because we are doing the whole service discovery thing. So you can actually create an endpoint reference, and it will inject the actual endpoint into your environment variable. And that worked. We have the sidecar, which we had extra options to because we were getting request times out when we were uploading PDF files because they were too big. Bunch of extra stuff there. And then we wait for SQL. We wait for the database to be ready. So if you would run that in the dashboard, you would see that it's in a waiting state until the database is spun up, and then it will start spinning up itself as well. So that's how that works. This, for example, is how you can still reference a Dapr YAML file. We have one that defines our file store to point to the Azure file storage or table storage, blob storage, sorry. And that's the way to do it. Okay, so that was a lot of talking about the whole development setup. And just to show you or to tell you how much this helped us, onboarding a new developer, going from git clone, opening the solution, figuring out what to start up, seeing that everything's connected correctly, that that the entire environment has been set up. You know how it is, right? It takes hours. With this, git clone, set app host as startup, F5, everything runs. First try, every single time. This saved us a lot of time when onboarding new people. So only for that, I would definitely use Aspire again in every single project. But then there's the deployment story. If you look at the official demos, then there's the azd up command. You define everything in your app host, azd up, everything gets spun up in an Azure environment. All your containers are being generated. There's stuff flying all over the place. Impressive demo. No one will use it that way. This is the new right-click publish. You run this from a developer's laptop. That's not the way to do it. Things have improved greatly by now, but this was the story when we got started. So we're in 9.3 now, and what you can do in the app host, you can now define that you just want Docker Compose files, or you want the Kubernetes files to deploy to, you want bicep files, and it will just create those files, which you can then check into a pull request and push them through your pipelines. Big improvement. Back then, that was not the case. So our deployment story was Terraform for the environment, which looked like this. So with Terraform, you first do a plan. There is a state file somewhere on Azure that contains the current state of your environment. The plan stage of Terraform will compare that state with your Terraform files, and then it will generate a Terraform plan, what it's planning to do. So this is a snippet, an example. You see the init container right there at the bottom, for example. Everything with a green plus sign is new stuff that will get added. Then there's a manual validation, and I cannot stress the importance of this. Always go over your plan before applying it, because sometimes it does really weird things. Once we go through the manual validation, it gets applied. You get an overview of all the things that get applied, and then it jumps to the next environment. That's how it was set up for us. Worked pretty well. Then there's the actual deployment of the different containers. Again, it's all containers, so there's a container registry in Azure that we push everything to. And then we just pull in, if you want to go from dev to test, for example, we just pull in the container image, we retag it for test, we push it to the next registry. We use the Azure CLI task in Azure DevOps to send the AZ container app update command. Container will spin up a new revision with the new image. We'll spin down the other one. Done. Update finished. Very, very little downtime. Works pretty well. Now, since we were maintaining our infrastructure with Terraform, Terraform not being a first-party thing for Azure, they were sometimes slow in adding features. And we had to work around that. An example here is if you open a Blazor server application in your browser, what happens is it creates a SignalR connection, a WebSocket connection to your server. And all the updates that you do, all the interactions that you do with your web page, they go over that SignalR connection to the server where they're being handled, and the response comes back as a diff of your DOM. Since we're working with containers, there can be multiple instances. And the one that you're currently working on might crash and spin down, and you might be connected to a different one all of a sudden, which means you would lose your state, which is not something that you want. So in the Azure Container Apps environment, there is a checkbox that says enable sticky sessions, something like that, which basically means that if there's an existing session, but you need to jump container, your session will move with you. That option was not available in Terraform. It was available through the Azure CLI. So we had an extra build step that every time we update our environment, we would run through our pipelines this command to enable sticky sessions. Just to show you what kind of things we had to work around because of technical problems. And that cost us time to figure this out. So, to conclude, .NET Aspire really helped us with our development loop. If you're working with different applications that need to start up at the same time, you need to onboard new people all the time, this will really help you speed up your process. Also, connecting everything together, not having to figure out what the real addresses are of all the services for every environment, having to constantly change app settings, make sure that everything gets injected correctly. Not having to do that anymore really helps. For Dapr, it worked as expected. The only downside that we had with Dapr, if you get exceptions in your, for example, in the demo I showed you with the method invocation, if you get exceptions there, the actual exception gets swallowed. You don't see the actual exception. You see this kind of really weird stuff in the console because this is going over gRPC. So you have to rely on logging and tracing to get the real exception, which is kind of more complex to figure out. That was a big downside. But apart from that, everything worked. It's technology agnostic, so if you're doing a project with different technology stacks, this will definitely help you. For future projects, I would almost always use .NET Aspire. Dapr, it would have to depend on the situation over in. So that was in short what our experiences were with the combination of these two technologies. I really hope that this kind of helped you to go beyond the demos that they've shown you and the getting started articles of Aspire. If you have questions for me, if you want to know more experiences of this, come talk to me. I'll be happy to help. I think we have time for a couple of questions, if there are any. No? Okay. If you want to see, or if you want to go through the demo that kind of looks like the project, that's where to find it. And with that, I wish you a pleasant rest of the day, and thank you all for being here.